Hello everybody. In this video I'm going to talk about one very important point regarding the calculation of the mass transfer coefficient, which is regarding the physical properties and how we can get the physical properties of the system that we are working on. So in most of the cases, and this is something that we discussed in chapter 27, which is the mass transfer between phases, that we deal with more than one phase. We can do this mass transfer calculations for mass transfer between gas and liquid, between gas and solid, between liquid and solid, depending on the system that we are dealing with. And in this case, we will sometimes when we go through the calculations and doing and getting the properties and doing all the calculations for Schmidt number, for Sherwood number, and for Reynolds number, we can get confused because of the phases that we have. So do we have to go with the properties of the liquid or properties of the gas? Especially it's the same species that is diffusing or transferring from a gas to a liquid, or from a liquid to a gas. So this is in many cases a very big source of confusion, and that's why it's important to be clear before you start to have a clear idea which mass transfer coefficient you are interested in. So the mass transfer coefficient will dictate the properties that you are looking for. So for example, if this is a water drop that is evaporating and the water is diffusing or transferring from the liquid phase to the gas phase, so it's just evaporation, normal evaporation. So in this case, you have a liquid phase and a gas phase, and because it's a pure water drop, then there is no mass transfer in the liquid phase, because it's concentration of water is everywhere in the water drop. So mass transfer is only taking place in the gas phase. So in this case, the properties that you are looking for, or the properties that we will use to calculate Reynolds number, Schmidt number, and Sherwood number, which are density, viscosity, the diffusion coefficient, will be the properties of the gas phase. So this is a rule that you have to keep in mind, that the properties that you use are the properties of the phase of interest in which the mass transfer takes place. So this is one very important point. We know that in many cases you will have two film, according to the two film theories, then you will have two films, one for the gas phase and one for the liquid phase. So if you want to calculate the mass transfer coefficient for the liquid phase, then you use the liquid properties. If you are calculating the mass transfer coefficient in the gas phase, then you use the gas properties. So this has to be very clear before you start, to prevent the use of wrong properties for the system or for the mass transfer coefficient you are calculating. The second point is regarding the temperature. So to calculate the properties, you have to know first the species, the phase, and this is something that we have we just discussed here, that you can tell which phase based on the mass transfer coefficient you are calculating, and the conditions, and mainly the most important is the temperature. So you have to know exactly what is the temperature at which you are calculating the physical properties. And this is something that it's very well known, that you can have tables for the properties as a function of temperature, and you can see, like for air, for water, for any liquid, for any gas, you can see that the properties will change with temperature. So you have to make sure that you are picking the right temperature. And in a case like this, for a water drop that's evaporating, you will have difference in temperature between the water drop and the air, and this is something that you can expect, and we know from energy balance and from psychrometry and many other things, that you can tell that there is a difference in temperature between the water drop and the air surrounding it. And in this case, you have to tell which temperature you should use to calculate the physical properties. Again, this has to do with the theory that we use, which is the film theory. The film theory assumes that 99% of mass transfer takes place in a very thin film, which is this film between the gas phase and the liquid phase. Beyond this film, mass transfer is almost done, and you have homogeneous concentration in gas phase and homogeneous concentration liquid phase. And that's why this is where most of mass transfer, or almost all mass transfer, takes place is in only this thin film. So the properties of the gas that you need to use for the calculation of mass transfer coefficient will be the properties of the gas in this film, according to this theory. The temperature here is not the gas temperature and is not the liquid temperature. It's something in between, which is an average temperature that we call the average film temperature, which is the liquid temperature plus the gas temperature divided by 2. So this is the temperature that we use to calculate the film or to get the physical properties at, and this is because we have difference in temperature, and the film theory says that we need to use the properties of the film. Of course, if you have a case where you have a same temperature in gas and liquid phase, then you don't have this issue, and you will not need to calculate any temperature because it's the same. But in the cases where you have difference in temperatures, you need to calculate the film temperature and not calculate or get the properties at the gas temperature. This is a point that's very important. That's why I wanted to keep it in a separate video. And we will see in the next video a problem that we will solve, and we will go through this step in more details. So I'll see you then, inshallah. Goodbye.